Hey, Miss O'Halloran here again, and we're going to finish up talking about our toolbox functions. So today we're going to talk about our rational and rational square functions. And we're going to have to identify those same characteristics to graph it that we did on the previous toolbox functions. Let's get to the first one. The first function that we're going to talk about is our reciprocal function. The reciprocal function has the formula y equals 1 over x. This is our parent function. And so our transform function still uses that a, that h, and that k. The difference is this does not just have one piece to our graph. Our graph is a multi-piece graph. And it has these things where our graph approaches and never crosses, which are called asymptotes. And that's what our h and k tell us here this time is our asymptotes. Let's go ahead and talk about this. So our asymptotes on these are 0. I mean, is our domain. It goes from negative infinity, it stops at 0, and then goes again after. So this is saying it's everything, there's a graph everywhere, but at 0. And our range is going to be the same thing because a 0, our horizontal asymptote at 0, also is not is excluded from our range. And so we can look at our asymptotes. X equals 0 is our vertical line right here, our vertical asymptote, and y equals 0 is our horizontal asymptote. The way I remember this is vertical lines go through the x-axis, and so they have an x equals equation. The horizontal asymptotes go through the y-axis, so they have a y equals equation. So here's our reciprocal square, which I realized I didn't write on there. So our reciprocal squared function looks pretty much the same except for it's squared. Our transform function, once again, looks exactly the same except for it's squared. Our graph, though, is a little bit different. If you recall, when you square something, that means it's always positive. So our graph is all above the x-axis on this one. Now, if we transform it, so if this k is negative, it could move this whole graph down. We could also flip it over if we had a negative a. Our domain follows the same domain as it did last time, so negative infinity to 0, and then 0 to infinity. But our range starts at 0, not including 0, and goes to infinity. But our vertical and horizontal asymptotes are the same as they were last time. And once again, these are found by our h and k values. Let's do a couple examples here. We'll do an example of our reciprocal function and then our reciprocal square, I believe is our next one. Yep. Our first thing we want to do, let's see, we find the x-intercept, y-intercept, our vertical asymptote or horizontal asymptote, domain, and range. I like to find the vertical and horizontal asymptotes first because those are visible right in our equation. Remember I said those are found by our h and k. If you want to think about it this way as additional notes, our vertical asymptote is always x equals whatever that h value is. And our horizontal asymptote is y equals whatever that k value is. And it's always the opposite of what's with our x. So that means our h is 3 and our k is 6. That makes our vertical asymptote x equals 3. And our horizontal asymptote y equals 6. Now, why do I want to do those first? I like to graph those. I'm going to use I'm going to use a light yellow color here so we can see them, but they're not actually part of the graph. We just want to make sure we don't cross those. Horizontal is at 6, which puts us right here. And our vertical is at 3, which puts us right here. Those are now our horizontal and vertical asymptotes. So our graph's going to be centered around that. Let's go ahead and find our x-intercepts. To find x-intercepts, it's the same process as we did last time. You plug 0 in for the y. So 0 is going to equal 2 over x minus 3 plus 6. Let's subtract our 6. So negative 6 equals 2 over x minus 3. And you always multiply by the denominator to get rid of it. We'll take this times x minus 3. And this negative 6 will distribute. I will end up with negative 6x plus 18 equals 2 because these two values cancel. Subtract my 18, negative 6x equals negative 16. Divide by 6, so x equals 8/3 or about 2.7. That is our x-intercept. What color? There we go. X-intercept 2.7. If I were to sketch that, it would be right in here somewhere. All right, let's try the y-intercept. The y-intercept, we plug 0 in for x. Y equals 2 over 0 minus 3 plus 6. That makes it a negative 2/3 plus 6, or 5 1/3, which is about 5.3. And the reason I go to a decimal is mostly for graphing purposes. It's easier to estimate on a decimal where we're at. Our y-intercept, like I said, is 5.3. We come up here as 4, 5.3 would be right in there. We can see that this side is going to be right here, and because it's just a reciprocal, they're kind of in opposite quadrants of each other. The next step is to type this into your graphing calculator and get a t-table. I'm going to kind of show you how to do this with Desmos really quick. In Desmos, it is pretty easy to type these equations in and to get a table. I'm going to pull this over here real fast so we can see it. All right, this would be our graph. We can see here's our y equals 6 and our x equals 3. But what I'm really looking for is a t-table. On Desmos, if you click this and convert to table, now we have a table we can mess with. With that, let's see if I can make this do what I want it to do. All right, I can start plugging in points. So let's see, -2 is 5.6. That's getting a little excessive. We got 0, so 1 is 5. That's a good one to find. 1 is 5. 2 is 4. And then 3 we know is in the asymptote, so let's try 4 and 5. 4 puts us at 8. 5 puts us at 7. And then just for, oops, wrong thing. I don't even know where that typed, but that's okay. Just because we're going to type a 10 in here, because that's where my graph ends up. 10 is 6.3. Let's get things kind of situated back up here. 10 would be 6.3. There's where my extra numbers went that I didn't know what happened. 6.3 would be right about in there. And then if I wanted to, I could do a -10. That's going to be really close to that asymptote. It ends up being 5.8. It's really if you just want to help out with those graphs. And I apologize in advance, this is not going to go very well. These graphs approach these yellow lines, but they'll never actually cross it. Yeah, that wasn't too bad, but the side's going to be worse. Honestly, that's not a bad graph for a computer. And then we need to find our domain and range. Our domain, if you recall, had that break at 0. We always break at that vertical asymptote. We end up going -infinity, and our vertical asymptote is 3, and then 3 to infinity. Our range always breaks at the horizontal asymptote. So we go -infinity to 6, and then 6 to infinity. And there's your domain and range. Let's try a reciprocal square function. Once again, I like to find the asymptotes, and they are found the same way. Our vertical asymptote is by that h value, and that horizontal asymptote is by that k value. So our vertical asymptote is going to be x equals -2, and our horizontal will be y equals -3. And if we go ahead and sketch those, it makes life a little bit easier. The vertical is at -2, and horizontal is at -3. I've had people ask me, are you required to draw these lines? You are not. And in fact, the graph itself typically does not have these lines drawn on it. The only reason why I draw them is so that when I'm graphing, I make sure I do not cross these lines. Because if I cross those lines, that is an incorrect graph. Let's find the x-intercept. Plugging things in for y. So 0 equals -1 over x plus 2 squared minus 3. All right, add our 3, so we have 3 equals -1 over x plus 2 squared. Multiply this over both sides, which leaves me with, I've got 3 x plus 2 squared equals negative 1. Divide by 3, x plus 2 squared equals a negative 1/3. And if you don't catch it yet, square root, we cannot square root a negative. What does that mean? Well, what that means for us is when we are having to find the x-intercept and we can't, that means there is none. And you would write none. Don't write 0 because 0 is an actual intercept. We could actually have that. So you write none. Let's find our y-intercept. Y equals negative 1 over 0 plus 2 squared minus 3. Well, 0 plus 2 is 2 and squared is 4. So I've got negative 1/4 minus 3, which is negative 3 1/4 or negative 3.25. This time we do have a y-intercept, so that worked in our favor. Our y-intercept is negative 3.25. Here's 3.25 would be right here, which makes sense that we don't have an x-intercept because since it's a square, these graphs are side by side, which means if this one's over here, this one has to be over here. They are not going to cross that x-axis. At this point, we would just go through and find some other coordinates to graph. And like I said, you can use Desmos, you can use your graphing calculator. It's whatever makes the most sense to you. In this particular moment, I'm actually using Desmos. I'm just not going to pull that over on my screen this time. All right, negative 1 is negative 4. And then let's see, negative 2 is undefined. Negative 3 is negative 4. And then negative 4 doesn't belong right there. Toss that out of the way. Negative 4 gets me a decimal again, which I could actually see that. It kind of mirrors across. We'll do our best we can. I know this graph's going to be super close to this line up here. And then we drop it down and just do our best with our graph. Because everything is kind of just a sketch here. Okay. Let's get rid of that. All right, now let's find the domain and range. As we go across, we skip our vertical asymptote again. So x goes from negative infinity to negative 2. And then from negative 2 to infinity. And then our range, y goes from, now we start low. So we start at negative infinity, and it goes to that horizontal asymptote, which is negative 3. But then notice our graph stops. There's nothing above it, so that's as far as our domain goes. And this is graphing rational and rational square functions.